with describing motion with words, and we talked about what is a vector, what is a scale. We talked about distance versus displacement. We talked about speed versus velocity. And then we talked about the important formula that we use to find either one of them, the distance or velocity or time. We talked about the metric unit that we use, which is meters, seconds, or meter per second. We had an example, and now we talked about instantaneous speed, and we talked about how the slope, which is my rise over run, will give me the velocity, the value for velocity. We're talking about the slope that is the time versus position. Now we're going to talk about acceleration. So what is acceleration? We always, you always hear of that, like, oh, he sped, he accelerated, what does it mean in physics? So it's going to be acceleration. So acceleration is a vector quantity, right? And so I don't care about the direction of the object that is in motion. All you need to know is that acceleration is a vector quantity. And just by thinking of acceleration, what is the first thing that crosses your mind? I hope you said speed or velocity. So there is a relationship between acceleration and speed. So it is defined, acceleration is defined as the rate at which an object changes its velocity so an object is accelerating only if it's changing its velocity, in other words, right? So when we talk about changing velocity, we're talking about also time that has been moving and running, right? Or we can just say that we have a constant acceleration. What does it mean when we say constant acceleration? It does not mean that you have a constant velocity. All right, and we're gonna talk about this in more examples and worksheets. So let's write this down. Since accelerating objects are constantly changing their velocity, so as we move and as we speed, we know that we're speeding. That means we are moving, which means we do not have a constant distance. All right, so distance, this implies distance is not constant. All right, So if we talk about, let's say, a free fall body, like I drop a pen, like drop a pen, it's going at a constant speed, right? And there's an acceleration. There's an acceleration. And the distance is changing, even though it's going at a constant speed or acceleration, but the distance is getting either smaller or bigger. That which tells you that acceleration does not depend on distance, right? So now you just probably made up this conclusion that when we talk about acceleration, we're talking about change in velocity. This is like a small triangle, which means change in velocity over time. And acceleration is the change in velocity is the final velocity minus the initial velocity. All this divided by time. Okay? How do we represent acceleration? We're not going to write acceleration like this all the time. It's represented with an A, little a, which is equivalent to VF, which means final, minus VI, which is initial, over time. And this is your formula. Velocity, the unit for velocity is meter per second. Time is in seconds. And then, which means the acceleration is going to be in meter per second squared. And these are the metric units for acceleration, velocity, and time. And it's very important that you write down the units. Okay? All right. So, how do we, when we talk about vector quantity, how are we going to see, how are we going to interpret a graph or look at a graph and say, oh, this is the acceleration, it's moving up or down. So the direction, the title is going to be the direction of the acceleration vector. Okay? And so since acceleration is a vector quantity, that means it has direction. So the direction depends on two things. It depends on two things. One, whether the object is speeding up or slowing down. If object, how does this affect us? Because it's a vector quantity, that means it has a magnitude and a direction. Speeding up or slowing down. If object is moving in the positive or negative direction. So let's say we say that the car is slowing down. So for example, if the car is slowing down, that means I know that the acceleration is moving in the opposite direction of the motion. So if object is slowing down, then its acceleration is in the opposite direction of its motion. Okay, so we're talking about positive and negative values. And all this, of course, are things that can be represented in a word problem. They can be represented in a table. You can be given a diagram, and you have to find out the or interpret or do the CERs of that diagram. So let's do one example probably before moving on to the diagram. And that will be, I think, example number 5. So for example number 5, we have, I'm going to just say, find the acceleration of the object in motion. So what do you have given? You have a table. You have time, velocity, and then you got 0, 0. You got 1 and 2, 2 and 4, 3 and 6, and 4 and 8. Okay, that's one of your tables. So the question is to find the acceleration. Is your question mark, and you have all this given. So to find the acceleration, I know that the formula is V final minus V initial over time. So in this case, I will pick any 2 points, and substitute them here so that we can find acceleration. I always suggest that you pick points where you got zeros in them because it's really the easiest thing to calculate. So I would probably pick this and that. You can pick any one. It will still give you the same answer. So I would also suggest you do T1, V1, T2, V2, just to make your calculation easier. So that would be 8 minus 0 over 4 minus 0. Your acceleration is 8 over 4, which is 2 meters per second squared. You have to make sure you have the meter per second square. That unit is very important. All right. Now, some of you would ask, can I do 0 minus 8 over 0 minus 4? Yes, as long as you make sure that the ones that are lined up are together, are the ones you chose. Okay? It doesn't matter which one goes first. What matters is that they have to be lined up. All right? So by now we've covered kinematics in words and their formulas. Now the next lesson is going to be introduction to diagrams and CERs. So that would be it for now.